The following data were used in a regression study. Here's a scatter plot of the data together with the simple linear regression line. And the equation of that regression line is y hat equals 2.32 plus 0.637 times x. Construct a plot of the residuals. Do the assumptions about the error terms seem to be satisfied? So the residual plot that I've drawn has x on the horizontal axis. I could have plotted the fitted values y hat on the horizontal axis too, but the plot would look very similar. The first assumption about the error term is that the expected value of the error term is 0 for all values of x. And so we can assess that by looking at the residual plot and moving our eye from left to right as x increases, and as we do so, think about where the average of the residuals would be. And if that average stays fairly close to the 0 line, which is the dashed line on the plot, then there's no reason to doubt that assumption. And that's the case in this particular example. There's no systematic non-linear trend that we can see in that residual plot that would cause us to doubt this assumption. The next assumption is that the variance of the residuals is the same for all values of x. So now what we want to do is scan the residual plot again from left to right as x increases, and think about the variability of the residuals about that horizontal dashed line at 0. If we do that in this particular example, we see that the variability of the residuals for low values of x is quite small. The points are quite close to that dashed line, but as we increase x, that variability seems to increase, so that by the time we get to the right hand side of the plot, the variability is quite extreme. In other words, the variance of the residuals is increasing as x increases, and so that causes us to doubt that second assumption, that the variance of the error term is the same for all values of x. As soon as we have strong evidence in the residual plot to doubt even just one of the assumptions, then it's game over, and we shouldn't really use this simple linear regression model. So we don't even need to check the other two assumptions. The third assumption is that the values of the error terms are independent, and then the fourth one is that the error term has a normal distribution. We don't need to check those in this case because we've already become concerned that the constant variance assumption is violated, and so it only takes one assumption to fail for the whole model to be cast into doubt.